All right, in this video I want to do some more examples. These will be more algebraic examples, so expect lots of variables floating around. So for these first two, the prompt just kind of says to expand, but that can be a little bit ambiguous. So what I'm saying is we want to write our answers so they kind of sort of look like this. So for this first one, we start out with the log base 2 of the square root of xy squared over 8z. And what you'll see is there's lots of different ways to deal with these. If it were me, I think what I would see is I'm taking the square root of all of this stuff. So I can think about all this stuff being raised up to the 1/2 power. And when I have the log of something, in this case xy squared over 8z, raised up to a power, I could take that power down in front of the log. So I can call this 1/2 times the log base 2 of xy squared over 8z. That's definitely not the only way to deal with this. We can kind of distribute that exponent to each of these individual factors, and we'll end up with the same answer. Maybe I'll show you how to do it that way after I finish this way. What I see next is this division, so I'm going to use the second log rule that says when you're taking the log of a quotient, you can rewrite that as the log of the top minus the log of the bottom. Got to be a little bit careful though, because this 1/2 applies to both of those terms that I'm going to end up with. I'm going to end up with the log base 2 of something minus the log base 2 of something. And without these parentheses here, the 1/2 won't hit both of these terms. It'll just hit the first term. You don't need them up here because we all just have one term. But when you start using these log rules to expand things, you can turn a single term into multiple terms. Terms are the things that are separated by plus and minus signs, by the way. At any rate, what I was dividing was xy squared and 8z. So those would go in those two spots. I don't think you really need these parentheses, but I'm going to include them just to try to make it as unambiguous as possible. What I would probably do next is recognize that I have multiplication here, and I also have multiplication here. So what I can do is use my first log rule twice, use it over here and over here, to rewrite this as the log base 2 of x plus the log base 2 of y squared. And then from that, I want to subtract, and I have to subtract this entire thing, and this entire thing is going to end up being two different terms. So again, my parentheses are really important. It's the log base 2 of 8 plus the log base 2 of z. And again, you have some freedom in the order that you do these things, but I think what I will do in the next step is first I'm going to take care of this exponent, this 2. My third log rule says when I'm taking the log of something squared, I can bring that 2 down in front of the log. Note that I could not have done that in this step. And the reason why you couldn't bring this 2 out in front of this log is because both the x and the y aren't being squared. Only the y is being squared. If there are parentheses around the x, y, and then the squared on the outside, then you could take that 2 down in front of the log, because those parentheses would indicate that both the x and the y are being squared. But it's not in this case. The x is to the first power and the y is to the second power. So this 2 only goes in front of this log. I get the log base 2 of x plus 2 times the log base 2 of y. And then maybe I can distribute this negative through the parentheses just so I have less parentheses to deal with. I don't know if this deserves a whole line all to itself, but what I'm going to do to try to make this as easy as possible to follow, and you could probably do several of these lines in the same place if you wanted to, is I'm just going to rewrite the log base 2 of 8 as 3, because the log base 2 of 8 is 3, because 3 is the power that you have to raise 2 up to if you wanted to change it into an 8. And this is pretty expanded, but the prompt up here said to write it in this form, so I guess what I should really do is get rid of these parentheses and write it x, then y, then z, then my constant. So my final answer would be 1/2 the log base 2 of x, plus, and then for my y's I have 2 log base 2 of y, but the 2 and the 1/2 will cancel each other out. So I'll just get the log base 2 of y, and then for my z's I have negative 1/2 of these log base 2z terms, and then the 1/2 times the 3 gives me 3/2. So my final answer would look like this. To try to keep these videos somewhat short, I'm not going to resolve this a different way, but I'm just going to kind of show you the first step of what you could do if you had a different idea in mind. And what that would be is to take this square root and to distribute it down to each of these different factors, the x, the y squared, the 8, and the z. So I call it the log base 2 of x to the 1/2 power times y to the first power divided by, and maybe instead of 8, I'll write 2 cubed here. So 2 cubed to the 1/2 power is 2 to the 3/2 power, because 3 times 1/2 is 3/2, and then z to the 1/2 power. And if you go this way, you can almost see the final answer, right? 1/2 log base 2 of x is going to be this guy when I take the 1/2 down in front. Log base 2 of y will be this guy, minus 1/2 log base 2 of z. That's this guy. There's the 1/2, negative because it's down in the denominator. And then the minus 3/2, the log base 2 of 2 to the 3/2 power. Well, that's just 3/2, but it's negative because it's down in the denominator. So I won't go through those steps here, but I just wanted to show you another way you could kind of go about this to get the same answer. For this second problem, there's lots of ways you can do it. I think probably the quickest way would be to use your exponent rules first to kind of take this 4 and apply it to each of these 3 different terms and simplify stuff with exponent rules before you use any log rules. But for the sake of teaching you log rules as best I can, I think what I'm going to do is do this with log rules, and then maybe at the end I can show you another way. If you're using log rules, you might recognize that this is a whole bunch of stuff raised up to the 4th power. So I can take that 4 down in front of the log, and I get 4 times the natural log of all that stuff. In this case, x times the square root of y divided by z to the 30th power, and it looks like the x square root of y, the numerator only, is raised to the 3rd power. It's tempting to then take care of this 3 and bring this down in front of the log, but you can't because this entire fraction is not cubed, just the numerator is cubed. So what you instead want to do is use your second log rule and say I got something divided by something else, so I can rewrite that as the natural log of the top minus the natural log of the bottom. And note that this 4 applies to both terms, hence the importance of those parentheses. Sorry if I sound like a broken record, but I just know from experience that parentheses really kind of messes people up. Now what I can do is take care of this exponent. I can bring this 3 in front of this log, note not outside these parentheses, because the parentheses will apply to both terms. This 3 only applies to the first term, so I get 4 times 3 times the natural log of x square root of y minus the natural log of z to the 30th power. You could make a pretty good argument that I should have taken this 30 down in front of the log in that step. Yeah, I will, eventually. No real hurry. I suppose I could have done it just then. I'm going to wait a little while for no particular reason. What I want to do next, we'll again leave this 4 alone, and this 3 applies to this entire thing, but I'm going to break this up into 2 different terms. And I'm going to do that using my first log rules, the log of something times something, so the natural log of x plus the natural log of the square root of y. These parentheses make the 3 hit both of these guys, and then I got minus the natural log of z to the 30th power. These parentheses make the 4 hit all that stuff. Finally, I could use my third log rule a couple different times. I have the natural log of y to the 1/2 power, because the square root of something means you're raising it to the 1/2 power. So that 1/2 can come out in front of the natural log of y. And similarly, this z to the 30th power, I can bring that 30 out down in front and keep the natural log of z. Be careful to close all the parentheses right. I think that's what I end up with. And this is great. I don't think there's anything further you can do with log rules. However, it's not quite in the form that the problem suggested the answers look. So I guess I should get rid of some parentheses. I think it's easier to work from the inside out, so let's get rid of these parentheses first. Let's take the 3 and distribute it to these 2 terms. So I got 3 times the natural log of x plus 3/2 times the natural log of y minus 30 times the natural log of z. Note that that 3 did not hit this 30. It's only hitting these parentheses here. And now finally I can get rid of my outermost parentheses by taking the 4 and distributing it through. So I get 12 times the natural log of x plus 4 times 3/2 is 12/2, aka 6. So 6 times the natural log of y, and 4 times negative 30 is negative 120 times the natural log of z. Again, you could cut down these steps pretty significantly. I could take this 4 and distribute to the top and the bottom. So now this is 120 and this is a 12 here. And then I could take this 12 and distribute it to the x and the square root of y. What that would leave me with is the natural log of x to the 12th power times the square root of y to the 12th power. But the square root of y is y to the 1/2 power. So y to the 1/2 to the 12th, that's the same as y to the 6th. And then down in the bottom, the 4 times the 30 was the 120, which is the exponent on the z term. Might take you 2 steps to get here, but I think you can get here using exponent rules, and then you can see your answer again, right? The natural log of x to the 12th, there's the natural log, there's the x, there's the 12 after I use my third log rule. The natural log of y to the 6th, there's the natural log of y, there's the 6. And then the z to the 120th power in the denominator turns into this term. There's the 120, that's the exponent, minus because it's down in the denominator. And you know, these videos are getting kind of long. I like to keep them as short as I can, so maybe I'll call that good. Maybe I'll change this page to just expanding logs, and I'll make another video where I show you how to contract them. So let's call this good.